Okay, let's look at another type of a bit more tougher question, which came out a few years. Okay, this is a very common question. Okay, the issue about this question is that there's actually no diagram given. Okay, it's just a full paragraph of words, so students don't really interpret the question carefully. So can we try to break it down and sketch a diagram so that we can understand the question better? Okay, it says when a block of wood or mass 2 kg. So you see this statement, it's good to start to draw a simple, just sketch a simple well-labeled diagram. Okay, so there's a block of wood. So in this case, the block of wood is 2 kg. So okay, and this is the mass M, which is being pushed along a horizontal flat surface. So this is the flat surface. Okay, horizontal flat surface being pushed. So in this case, I just use the arrow to represent the pushing. Okay, the friction force measured is 4 Newton. So in this case, friction is acting opposite direction to the motion. Okay, so if I'm pushing it to the right, friction will obviously be pushing it to the left. So I label this as 4 Newton. Okay, when the block is pushed along the same block with a force of 10 Newton, it moves with a constant. Okay, so the question is constant what, right? So in this case now, it's given as 10 Newton. So I can label this as 10 Newton. Okay, so 10 Newton is my answer here. So you notice I have a mass, I have forces acting on this object. So with two forces acting on the object, my first conclusion I can make is the resultant force. So you notice resultant force is a single vector that can represent all the forces acting on the object. In this case, obviously 10 Newton is a bigger force, right? Okay, 10 Newton is a bigger force. So obviously my resultant force will be somewhere to the right. So I take it to the right, so it's 10. You notice 4 Newton is opposite direction, so I should subtract or minus 4. So in this case, my resultant force will be in this case it's just 6 Newton to the right. Okay, so I already solved for my resultant force. You notice with resultant force, I can actually apply my next concept, which is called F is actually equal to ma. So with a acceleration, I will have a resultant force. So in this case, I just substitute 6 is equal to 2 times a. So in this case, a is actually equal to 6 divided by 2. So it's give me the answer 3 meter per second squared. So with a certain resultant force, obviously I will also have a acceleration. So in this case, my acceleration will be 3 meter per second squared, which is also towards the right side. So my answer will be C. Okay, acceleration of 3 meter per second to the right. So this is my answer for this question.